Welcome to qnawire.
So we're given this function, which is equal to ax times e to the b times x squared. So what we're going to do is we're going to find the values of a and b such that f of 2, which is equal to 1, is a maximum. So we know that if f of 2 is a 1, or is equal to 1 is a maximum, that means that the derivative at 2 is going to be equal to 0. So the first thing that I'm going to do is find the derivative of f of x. And we're going to have to use the product rule and the chain rule to find this. So the product rule is the derivative of the first times the second. So a is just a constant. The derivative of x is 1, so we just have times the second, which is e to the bx squared. And then we have plus the first times the derivative of the second. And the derivative of e to the bx squared is e to the bx squared times the derivative of whatever's in this exponent, which would be 2bx. And now I'm just going to simplify this a little bit. And we can actually take out a times e to the bx squared out of this and factor that first. So that's what I'm going to do. And then we're left with 1 plus, we took an a e to the bx squared out, so we're left with x times 2bx. So this would be plus 2bx squared. And now we know that the derivative at 2 is equal to 0, so we can plug in 2 and set this equal to 0. So we can say 0 is equal to a times e to the 2 squared is 4, so to the 4b, plus or times 1 plus 2b times 2 squared, which would be 8b. And this is equal to 0. So now we have two factors that are multiplied by each other equal to 0. So we can set each of these factors equal to 0 and solve for our a's and b's. Well, if we solve for a in this first part, since e to the 4b can never be 0, we know that this b part is never going to make this a times e to the 4b equal to 0. So only a equaling 0 would actually give us 0 in this factor. But if we look at our original equation, if a is equal to 0, then our whole equation f of x is just equal to 0. So we don't want a equaling 0. So this is not what we want. So we're going to find what b actually equals, and that will be what we'll use. So if we minus 1 over, we get 8b is equal to negative 1, then b is equal to negative 1/8. So b is equal to negative 1/8, and that's what we want to use. So now we got to make sure that this is actually a maximum. So what we're going to want to do is plug in a value into our derivative that is less than 2. Let's plug in, let's just say 0, and we're going to make b equal to negative 1/8 since we know b is equal to negative 1/8. So if we do that, our original derivative was, I'll write that down here, was a e to the bx squared, which we now know b is negative 1/8, so this would be negative x squared over 8, times 1 plus, and it was 2bx squared, so this would be negative 1/4 x squared. And now if we plug in a value that's less than 2, so let's just say x is less than 2, let's plug in 0, we would have a times e to the 0th, which just would be a, and then multiplied by 1 plus 0, so this would just be equal to a. So for this to be a maximum, we would need a to be greater than 0. Since we want a to be greater than 0 so that our derivative f prime of x will be greater than 0 at x being less than 2, I guess. Which is what we want, since we want to go from positive to negative in order to have an actual maximum. So now if we look at values of x being greater than 2, let's just say 3, we would have a times e to the negative 9/8. So I'm actually going to just write this out. So this is equal to a times e to the negative 9/8 multiplied by 1 plus negative 1/4 times 3 squared would be negative 9/4. If we simplify this, this would be a over e to the 9/8 multiplied by 1 plus 9/4, or 1 minus 9/4 would be negative 5/4. So again, we would have to have a positive a value in order to have a negative value for our derivative for values of x being greater than 2. So again, we want a being greater than 0, which is good. If we wanted a to be less than 0 for this to be a maximum, then we would have conflicting conditions and we wouldn't actually be able to have a maximum with b being equal to negative 1/8. But it is good that a being greater than 0 is the condition for both of these. So now the only thing we have to do is actually plug in this value of 2 into our original equation, which was ax to the times e to the bx squared. So this is to the negative x squared over 8. And this is actually just f of x, not f of 2. And now if we plug in f of 2, well, we know f of 2 has to equal 1. So we can say 1 is equal to a times 2 times e to the negative 2 squared is 4 over 8 would be negative 1/2. So now we can multiply by this e to the 1/2 on both sides to get rid of this e. So we get e to the 1/2 is equal to 2a. So a is equal to e to the 1/2 divided by 2. So we've now found the values for a and b, where a is equal to the square root of e divided by 2, or e to the 1/2 divided by 2, and b is equal to negative 1/8.